So again, as I was saying today, right now, this lesson 5.6, lesson 6 of this unit is assuming that you had a chance to take the previous lesson home and sit on it a little bit. So if you're still a little shaky on creating an equation, that makes sense because you never got an opportunity to try homework. All right. This is why I'm helping you. Option A, my initial value, in other words, if I stay 0 days, I don't have to pay any registration fee. So my initial value is 0. I am paying $50 per day, keyword. That should tell you what the rate of change is going to be. 50/day, 50 per day, or 50/1. Looking at that as your rate of change, the two different things in this fraction should tell you what my X and Y value variables are. The $50 a day should tell you that money is going to be, or the cost is going to be my Y. The days means X, that's going to be how many days pass. My equation is, remember, Y equals mx plus b. Write an equation that relates to the total cost, so that's going to be C. And the number of days, n, so that's going to be n. Y equals mx plus b. For option A, it's going to be Y equals mx plus b, which is 0. Time to do option B. I'll go through this relatively quickly. Because there's a registration fee, I know that my starting amount is 100. It's $40 per day, which means my rate of change is 40 per day, or just 40. My cost is C, my N is, so my days is N. C is equal to 40 times the number of days plus 100. So I have two equations. I'm going to write this down. C equals 50N. C equals 40N plus 100. And that's it. Let's plug it in, people. Could you do that for me? Oops. Take that. There. Let's fill in this table. I'll give you a minute. And as an example, if you have no idea how to do it, remember the days skied is 2. 50 times 2, the cost would be $100 for the 2 days. 4 times 50, the cost would be 200. Continue this on. For here, the days skied would be 40 times 2 plus 180. There. 40 times 4 days plus 100 would be there. Please fill this in quickly. Okay, filling in the chart, this is what you should see. I am going to take these data points and graph it here. Let's see, blue starts with $100. 0. I pay 100, pay 200, pay 300, pay 400, 500. And that is okay. And then let's do red. That's pretty big contrast. $100, 180, 160. So 320, So 40, 100, 420, and then 500, and then 580, 660. All right. So if you are graphing this correctly, you should see two different colors, not only mapping out two linear relationships, but those two linear relationships also have a relationship. What can you tell me about the two pathways that you see here? Very simple. Just what do you notice? Yes? They're crossing. And the word I want us to use is intersect. And that is the answer. So let's label this a little bit more properly. So this, the x-axis would be number of days that we spend. So that would be n. The y variable is the dollar cost. Oh, that's hard writing vertically. And that's the letter C. Yeah, there is an interesting point. So I am going to fill in the blanks below, but I'd like you to consider this part right here. That's a nice circle, don't you think? Here we go. That point right there is called the point of intersection. Well, wow, what's wrong with me? Intersection, otherwise known as POI. And that's a really important part of this thing called linear system. It's a really, bless you, a really important part. So some of you are still working on the graph. Please make sure you add and label this point of intersection. And we'll start answering some of these to analyze the graph correctly. So while you're working on that, question? We will be having some kind of, I think, assignment of sorts, not a quiz anytime soon. Like this Friday, I'll probably have an assignment. Oh, thank you for reminding me. Everyone here, we are going to have an in-class assignment based on linear relationships. In short, what are we doing? We're going to do an assignment called the Barbie bungee jump. Now that's really weird sounding. However, we are going to be taking real life data and plotting it and turning it into a graph. I'm pretty sure, I'm 90% sure that we have enough random Barbies to bungee jump. However, if you have a particularly favorite stuffed animal or an action figure or some kind of toy that's relatively heavy that you're comfortable dropping, right, from like the 3rd floor, I invite you to bring that on Friday. Yes? Where are we dropping the Barbies to? Well, do you see the staircase? We already have staircase. Essentially. The only place where we get enough height would be even from the 2nd floor, dropping down to the 1st floor. There's enough depth for us to actually measure. So we're probably going to do that. The worst case scenario, we'll set up a tape measure on the wall and we'll get people to stand on the tables and stuff. I don't know. Yes? Wait, are the Barbies just going to be like falling or is it going to be like You know this. Oh. In science? Oh, yeah, that makes sense. Okay, so we'll work on that. I believe I will make a formal announcement of it on with more detail on Wednesday. I'm pretty sure that we have it scheduled for this week, but stay tuned. All right. So point of intersection, as we move on. Look at the points where the two lines intersect. This is called the point of intersection, aka POI. What is the value of n at this point? Please take a look at your graph. What is the value of n at this point? What is the n at the point of intersection? That's not n. What is n? Yep, 10 days. Yes. So this is the importance of recognizing what the variables are. By n, I actually meant the x value. It means the number of days. Okay. This is really important. Listen up. Maya up here. Patrick up here. Arvin here. Everyone up here. Super important. E and F. Look to the left of the point of intersection. So we have a graph. Here's one line. Here's the other line. Look to the left of the point of intersection. Which plan is cheaper? How do you know? Which plan is cheaper? How do you know? Brown? Option B is cheaper. Look carefully. Which line is lower on the left side of the point of intersection? So this line should be option A. And that line should be B. Would you agree? So A is actually low on the left side. Which plan is cheaper? Option A. How do you know? Very simple. Okay. So Y value, which is the cost, is below the other line. That's it. It's lower, so cost is lower. In the same way, I can do that with the other. Where's my red? So here's one line, that's A. Here's the other line, that's B. And I want to look at the right portion of the point of intersection. Which plan is cheaper? Well, you can tell. Option. Why is it not working? Option B is cheaper. Why? The Y value, cost, is below the other line. So whichever is lower is the cheaper option. That sort of makes sense, doesn't it? And this is where Ryan comes in because he answered G already. Find the cost of both plans at that point of intersection. 500. What does that mean? What's the significance? Why do we even care? What's so special about the point of intersection? What is the meaning behind the point of intersection? Pardon? There's no better value on both sides. They're equal, right? So the graph, big whoop, it's a graph. What you pull out of it is just as important, if not more important. Okay, so question G. Find the cost of both plans. What is the significance? So let me write this. Right? Cost is $500. This means if you know you will stay 10 days, either plan will be of equal value. One plan isn't better than the other, it's equal. Shameless plug into things like business. Shameless plug into things like money. If you can create an equation, let's say this is your profit and this is the cost, certain things are going to be really, really interesting to put together in the future. Anytime you have two equations and you want to compare them, anytime. Some of you will understand because you have a business mindset. Others are like, oh, whatever. But we'll get there, I'm sure. All right. We still have a lot of time, and here is me being greedy. I want to show you a much more heavy mathematical approach that you can solve for the point of intersection without a graph, without tables, without really any data, but just equations. And that is called substitution, right? In fact, this is what you start with in the previous grade 10 course. So what we're doing right now is, again, I'm just a little selfish for you. I want to show you. And some of you who see it, you're like, oh, that makes a lot of sense. Other people will be like, no, I'll wait until next year. Either is okay, but I want to show you. You can solve for this silly point of intersection using just the equations. Here we go. When you're ready. Rather than creating a table of values, we can also find the point of intersection for two linear equations using something called substitution. As in you substitute, you know, like substitute teacher, you're replacing. Let's take a look. This is equation 1. This is equation 2. Really important. Ethan, up here. So far, so good? Everyone's okay? What did we just say about these two equations at the point of intersection? What's so special about C and N at the point of intersection? They're going to be equal. We just said that this cost and this cost is equal. So I'll write it right here, and you can follow along. When is the cost equal? So if they are equal, well, we already know the answer, which is, Ethan? $500 at 10 days. We already know that, but let's pretend we didn't. Even though if we didn't, we know that the C of the left side and C of the right side are going to be equal. Then can't we argue, since C is equal to C, then doesn't that mean 50N will also equal to 20N? I'll say that one more time. If I know that C here is equal to C here, and these two are equal, then can't we argue that this is also equal to that? Do you follow my logic? I'll say it one more time. C could be written as this box, but C could also be written as that box because these two shaded areas are going to be exactly the same. In other words, I can take this C and substitute it with that box. What I'm trying to say is, instead of writing a C here, I can write this is equal to that. So the math might be a little bit rough, but the logic you should be able to follow. The math might be rough, but the logic you should be able to follow. This C is one and the same. So these square rectangles should also be one and the same. That's why I made them equal. And the rest is algebra. That's group-like terms. Marshall, it's okay. Marshall, I want all the n's in one side. How do I get rid of 40n? Let's make this disappear. Yes, minus 40n, minus 40n. 100 equals 10. Marshall, keep going. How do I get n all alone? You don't have to guess. That's absolutely right. Divide both sides by 10. N equals 10 days. You could do it by graph. You could do it by t-tables. You could do it by equations. The point of intersection, math is just a language where any angle you go, you can get the same result. It's just a matter of you being able to speak all aspects of it. Okay? It might be a little bit rough, but again, what you just did here is the beginning of grade 10 math. And if you're able to follow it, good for you. If you're not, at least understand the concept, the idea that you can substitute things in, and the math, the logic behind that is just as important as being able to do the math. So I hope that you'll be able to follow through. The very last part is just a quick check. Is everyone okay with this? Here's what I'm going to do. I'll save this just in case. Now that we found the point of intersection algebraically, in other words, the n value is 10, right? If the point of intersection is 10, I will test n equals 9 and n equals 11 to see which one's the better deal. So n equals 9, if I have 9 days, which one's the better deal? If I have 11 days, which one's the better deal? Okay, 9 days. C equals 50 times n. C equals 50 times 9. How much do I pay for 9 days? $450. Okay. C also could equal 40 times n plus 100, which means 40 times 9 days plus 100, which means 360 plus 100, which means 460. Which one is cheaper? Option A. Does that agree with my graph? I'll do it one more time. C is 50 times n, so 50 times 11. If you put that into the calculator, 550. Okay. C equals 40n plus 100, so 40n plus 100. This is, I'll do it for you, 440 plus 100. That is 540. Which one's cheaper? Does that agree with my graph? So again, just without graphs. So what I'm trying to show you is, yeah, whether you do it again by a graph or a t-table or equations, they all are exactly the same thing. But as I said before, you have to be well versed with all the different styles. If I give you a T-chart, you got to be able to do it. If I give you just graphs, you got to be able to do it. If I give you equations, you also got to be able to. That's the challenge. I know it's a lot. We still have over 35 minutes, which you are allowed to use as you see fit. You can do whatever you want, but if you want my recommendation, please don't sleep on this. This is essentially the core of grade 9 math. These kinds of things, okay? And we use this as a basis for grade 10, as I just said. So please don't sleep on this. I know you're tired. Take a 20-minute nap. I don't care, but make sure you come back to these questions as well.